Okay, so everybody, let's pick up where we left off last time. So the last thing we worked on was writing the code for a hockey player. And the hockey player class is an extension of the person class, so it is a person, but it also implements the hockey interface. And just as a reminder, interfaces are places where all the methods are abstract, and you don't have to define them as abstract, which means they have no method body. You just end in a semicolon. You define what needs to be done in the method, not how it needs to be done. And interfaces can actually extend other interfaces. So the hockey interface extended the sports interface, which had 2 abstract methods in it. We also wrote a football interface with 3 abstract methods in it as well. Now those methods can include parameters and, if necessary, return types, but it doesn't define how they're written. When you then get to the class that implements that interface, then you will have to actually define the method. So that's when you implement the methods. And here they are, all the methods of the hockey interface. So these 3 methods will appear in the hockey player class. But also, because the hockey class extends the sports interface, those 2 methods are also needed to be implemented within the hockey player class. So let's take a look at it this way, okay? So now that we have classes, and classes themselves contain a collection of properties and methods, and if we use something like a UML diagram, we can define the properties as public, private, or protected using symbols. Same with the methods. We can define parameters and return types and data types within the class. We can also now describe abstract classes by maybe just placing it in italics. Same stuff applies. And also interfaces, which are also in italics, but I'm just including a few more symbols here to imply that the interface is there. When we talk about the relationships between class, we can talk about composition or association, where one class has another class or associates, and inheritance, where one class inherits or is another one. And now we can even imply a enforce the rules of or implements relationship. So if we apply this to the example we have, this is the relationship between all our classes. So we actually started back here with some examples in our main method. It's running a testing class, which creates a person. The teacher and the doctor and the student and the hockey player all inherit from person and its methods. The meeting class just uses the person class, so it's an association there. Going further down the list, a computer science teacher is a teacher. A Mr. Walks is a computer science teacher. That's inheritance. The high school student is a student. That's inheritance. And then the hockey player implements the rules of hockey, which uses as well the rules of sports, and football we haven't touched yet. So altogether, it's a pretty complicated relationship. But let's fill out this hockey player class. We got to actually fill out the details of the class itself. Let's start with some properties. Let's make them private. We need a string for the home team and the name of the home team name. We're going to need one as well for the visiting team name. Okay, so visiting team name. We're going to need to keep track of the score, so private integer for the home team score. How many points do they have? Whoops, let's fix that up. Oh my goodness, let's try that again. And one for the visiting team score. These are the 4 variables that I'm going to need to remember in this class. These are the things I'm going to need to remember to be a hockey player. What's my name for the home team? What's the visiting team name? What's my score? What's the visiting score? All right, let's set up the constructor. So the home score, the home team score, equals the visiting team score equals 0. So we set everybody to 0. We should also probably set the names to nothing. So let's do that. Home team name equals visiting team name equals nothing at this point. So they have a blank name. Okay? So these are all set in our constructor. Now, a hockey player is a person, so we should probably also pass a few more information to it. The name of that person, the age of that person, and whether or not this person is a male. Okay? So let's take a look back at the classes we have, which we've seen in our diagram, and they're all in here. Whoops, not that one, this one. So they're all in there, including all the way back to our person class, which, as you remember, has a name, an age, and is male, and a constructor that goes with that. Okay, so with that person class, let's apply that to now our hockey player. So first thing we'll do is we'll call the super constructor and pass it the name, the age, and the is male. So those properties are set in the superclass person. All right, now for some easy ones. What happens when a home goal is scored? Well, the home team score goes up by 1. In hockey, you go 1 at a time. Okay? Same with the visiting team goal. Then the visiting team score goes up by 1. Those are pretty simple. Set the home team. Well, then the home team name equals this name. That's a mutator method. Same with the visiting team. The visiting team name equals this name. That's a mutator method. These are also mutator methods when I score a goal here and here. And let's define what happens at the end of the period. So at the end of a period of hockey, let's output a little information. It's the end of period, and we'll attach the parameter, period. That's which period's ending. And the score is, we'll attach the home team score for the, and I'll attach the home team name. And now I'll attach the visiting team score for the, and I'll attach the visiting team name. Okay, so for example, it would be, end of period 1, and the score is 3 for the Winnipeg Jets and 2 for the Calgary Flames. And this fleshes out now all the details of what our hockey player needed to do. Obviously, if this was a real piece of code, we would add more and more features to the hockey player. But you can see here, by implementing those rules of hockey, it set at least a bunch of methods in place for us to use. So let's put this to the test. Let's test our hockey player. So let's create a hockey player. Okay. We'll call it Jet equals a new hockey player. Okay, so the name of this hockey player. All right. So the name of this hockey player will be Dustin Bufflin, which I cannot spell correctly. Age, about 30. Is male, yes. Okay, so there is a set of properties, for our hockey player. Okay, now let's go to Jet and set the home team. Winnipeg Jets. Let's go to our Jet and set the visiting team. Calgary Flames. All right, let's play some hockey. Jet dot home team goal. Jet dot visiting team goal. Jet dot home team goal. Jet dot end of period 1. All right, let's run this code here and let's see what happens when all this code now plays. All right, so it's the end of period 1, and the score is 2 for the Winnipeg Jets and 1 for the Calgary Flames. All right, that worked out nicely. And it worked out through our interfaces, which was really convenient. All right, let's add another interface to our project, a new Java interface. This interface is going to be called the permission form. Okay, so the permission form. Oops, let me capitalize that F. A permission form. So this will be a set of rules for school students who who have to go away and they have to join a team. They have to sign a permission form. All right, so let's finish that. So interfaces, as you remember, are very simple, and they just contain abstract methods or abstract properties. So let's start with that. Let's create a public static final Boolean called isSigned. And we're going to set it to true because it's a final, so we can lock it in right now. This permission form is signed. And we'll make a similar one for when it's not signed. I'll make that false. So these are properties, two properties of the class, pardon me, of the interface. Now let's add some abstract methods. Public, void. So an action would be to sign our permission form. Sign the permission. We'd sign it. Actually, let's just keep it. Sign it. Okay. And let's make another method. This one returns a Boolean. Is, or does this person has permission? They either has permission or not has permission. There we go. That returns a Boolean, yes or no, true or false. And that's it. That's our whole interface. Two properties, two methods. Defining what needs to be done, not how it needs to be done. Let's change this when I change my mind again. Let's make this that they sign the permission form. Make it a little more formal. So this is the action of signing the permission form, and this is the action, do they have or has permission? It returns true or false. All right? So that is now another interface in amongst all our other classes. Now what I want to do is use this interface with a new class we're going to create, which is an extension, if we look here, of the high school student. So we're going to extend into the high school student another more specific type of student. So let's now create another new class. And this will be a high school student right here at this high school, Sturgeon Heights. And we know that we are called the Huskies. So this type will be a Husky. So Husky is a high school student, a specific high school student. Finish. Okay, so as we know, our template is already written in 4 methods. Our constructor method, our toString, our equals, and our clone method. That's nice, but we're not done yet. With the signature line of the Husky class, a Husky extends, okay, so a Husky is a high school student. Okay, so that's good. That immediately makes the constructor invalid. So why don't we get rid of that constructor for now. If we wanted to, we can build it, but let's hold off a little bit because we're not done with this line. Not only does it extend the high school student, and I'm running out of space, but it implements a permission form. But the nice thing as well with interfaces is you can, unlike classes, with classes in Java, you can only extend one class. Inheritance only works on one class. But with interfaces, you can implement multiple interfaces by putting a comma there. So a Husky enforces the rules of permission form, also enforces the rules of hockey, and also enforces the rules of football. So a Husky implements all 3 interfaces. So now when we look at this light bulb, pardon me, this light bulb, when we say we want to implement all the abstract methods, there's going to be quite a few here. So now as we scroll down this list, sign the permission form, has permission, home team scold, visiting team, end of the period, set home team, set visiting team, home team scores, visiting team, and end of quarter. These are all coming from different interfaces, and it's now saying you got to write these lines. And in addition, we also need a constructor. This is just handier that it will student number, name, age, and gender just get pulled in, and then the super constructor is called for us. So it just makes life a little bit easier in terms of writing that constructor method for what is now our high school football student, or pardon me, our high school student. And a lot of code just came into play here. All right, so we might as well make this thing happen. Let's set up some properties. First of all, I'm just going to steal a bunch from the hockey player class. We're going to need these same 4 things up here. So I'm going to steal those. Home team, visiting, home score, visiting score. Sure, that works. We need one more, a Boolean to determine do they have permission. So is permission granted? We'll make that a little Boolean property. I'm also going to steal from the hockey player class these 2 lines to set the home team and the visiting team. And is permission granted will be set to false. I'm going to assume that no one has permission to play sports when they're first created as a Husky student. Okay. Now, still got some errors here. The error is right here. Do they have permission? It's a return method. So, okay. For now, let's just have it return false. We'll fill that in a minute. When we put a stub method that returns something, we have to put something there just to make everybody happy that it's at least returning what it said it was going to be returning. Okay, we'll get to those in a minute. Let's actually put it to the test. So we're going to have a Husky.
Thanks for helping me.
Whew, sorry about that. Okay, so let's make a Husky. Let's just call it Husky. Equals a new Husky. And student number 105, name Havoc Husky. Oops, caps lock's on. Age 15. Is a male? No. There's our Husky. Okay, so we've actually generated Havoc the Husky. Student number 105, 15 years old, is a girl. Now, that Husky has access to all the methods of the high school student class, all the methods of the student class and the person class. So you can see here all kinds of stuff going on here, okay? All the stuff that can be done with that class. In addition, all the methods that were brought in with the interfaces, like end of the period, end of the quarter, signing a permission form, all of that stuff is in here for the Husky to use. But I think we're jumping the gun a little bit. Let's start writing out the Husky class. We did the constructor. The toString method, well, we'll do that, say, is Husky, exclamation point. So we'll add that into that. We did that with a lot of our classes, if you may recall. Even with the student class, when we wrote that, in our toString method, we added, student, and then the student number, right? We added that in there. So we're doing that with the Husky. It's going to output all the superclass stuff, and then is a Husky at the end. Okay. So actually, why don't we test that real quick right now? So let's just output our Husky. Okay. We play it, and there it is, student 105, Havoc the Husky, 15, is a high school student, and is a Husky. Okay. So that worked. I'm just going to take that line out. That's done. Our equals method, let's not put any effort into that right now. That could be obviously fleshed out more, but for now it's good. Our clone method, same thing. But let's actually sign the permission form. This is an important thing to actually think about. How do we sign our permission form? Okay. Well, we're going to set this variable, is permission granted, okay, is going to be set to true, or another way we can look at it is we can go to the class permission form, pardon me, the interface, dot is signed is one of our properties within that thing, and it is a shared property of the permission form because we made it static. So we don't actually have to create an instance, which we couldn't do anyways, because it is an interface. So permission granted, permission form is signed. Has permission. Well, let's just return this variable. Is the permission granted? We'll return that. All right, home team goal. Well, the home team score goes up by 1. This is a goal in hockey. The visiting team goal. Well, the visiting team score goes up by 1 because that's a goal in hockey. End of the period. Okay, we'll get to that one in a minute. Set the home team. Okay, so the home team name equals this name. This is exactly the same code as in the hockey player class. Same with this one. Visiting team name equals the name. Home team scores an amount. Well, this is football now. So in football, we score different amounts. So the home team score this time equals what it was plus that amount. Or we could shorthand that to plus equals amount. Remember, that means home team score equals home team score plus that amount. And we're going to do the same thing with the visiting team score. We're just going to change this home to visiting. All right, now we have the end of the quarter to write. But we also have the end of the period to write. So let's write that in the same way we kind of did it with hockey, with their hockey player. So we have this exact same piece of code, an output there. Let's put it in Husky. But let's add a little switch to this. Let's only do this if, okay, if is the permission form granted equals permission form dot is signed. So if it's signed, then I will do this. Okay, so this is now controlled by an if statement. If it's signed, then I will output this. Now I could normally just put an else here, but I want to do this for the purpose of just writing it in. If is permission granted equals permission form dot not signed, I'll output something different. Now, of course, I could have just put else because this is a Boolean variable, true or false. But I wanted to write that in just to sort of flesh out that little piece of code there. So it's not signed, so I'll output you cannot play hockey. Okay? So if I try to end the period without signing the permission form, that should happen. Let's put that to the test right now a little bit. So we just had our Husky created. Let's say Husky dot end of period 2, and let's see what happens. You cannot play hockey. Oh, okay. So that worked. Let's do something similar. So let's just copy and paste this into the end of the quarter. Let's change hockey to football. Okay. Let's change period to quarter, end of the quarter. The score is this for the home team and this for the visiting team. And now we have something similar for football. And we can test that. End of quarter 2. And it should say, you cannot play football. We don't have permission. Okay, so now we finished our Husky class. We've fleshed out all the methods. They're no longer stubs. They now have content to them. Our entire Husky is built with all its methods as needed. Let's put it to the test. So, okay, Husky dot set. Well, no, we better sign our permission form first. Okay, now Husky dot set the home team to be Sturgeon Huskies. Husky dot set the visiting team to be the John Taylor Pipers. That's my old school. Okay, Husky dot. Okay, all right. let's play a little of both. Let's have a home team goal. Let's have a Husky dot home team scores, that's football, 7 points. Okay. Let's take the Husky dot end of the period, 1. And let's have the Husky dot end of the quarter, 1. And let's run this code. All right, so it's end of period 1, and the score is 8 for the Sturgeon Huskies and 0 for the John Taylor Pipers. Now, why is it 8? Because we're using one variable to keep track of so it got 1 hockey goal here and 7 football points here. So it's a bit buggy. We could probably fix that. If we took the football part out and just played hockey like that, home team end of period, we'd probably get a more accurate end of period 1, and the score is 1 for the Sturgeon Huskies and 0 for John Taylor. That works. Or what if we played football but not hockey? So I'll take the hockey out. And now it's end of quarter 1, 7 for Sturgeon and 0 for John Taylor. So there's lots we can do with this, okay? Including, because a Husky is a person, one more line for fun, Husky dot eat a donut. Now, donut, as you remember, was one of our classes back here, one of our abstract classes, and because the eat method was built into the person class, it applies as well, and now donuts never spoil because I can eat them. Okay? So this is all that coming into play again, all that stuff that we've been building over time, starting to come together as part of this. Okay, we're going to wrap up there for now, so go ahead and hit that subscribe button if you like this video, and I'll see you next time.